Today we're going to start the next unit, which is a short unit. We'll have a quiz on it and a test on it after the break. Yes?
Wait.
And that'll be our last test. We will be having a test on right triangles before then.
Oh, I was about to say, we haven't even had the test for the.
Right, but there wasn't time to get the test in this week,
Yeah.
right? Because I wanted you to have the quiz to practice on, and want you to have a review sheet, all that kind of stuff. So we're going to go ahead and start the next unit today. So today we're going to talk about perpendicular and angle bisectors. And what I want you to imagine for just a moment is this. Don't worry about what's written there. As soon as I say that, people start looking at it. But let's say that this is nice level ground, right? And I had some sort of an apparatus that would allow me to sort of like when you have a microphone stand where you can adjust it higher or lower, right? So, and hopefully those stand perpendicular to the ground, right? We don't want it to lean to one side or the other. So if I had that perpendicular to the ground and I had like a bungee cord or something attached from here to here and here to here, and I made that longer and I just kept making it longer and longer and longer, assuming the bungee cords could continue to stretch. If these two are the same distance away from here, are these two bungee cords going to be the same length?
Yes.
Yeah. So as we and no matter where I attach the bungee cords on this, they're going to be the same length, right? That's the idea of this first theorem. We're only doing two theorems today. It says that if a point lies on the perpendicular bisector of a segment, then that point is equidistant from the endpoints of the segment. So the segment bisector is a line or a segment or a ray that goes through the midpoint of a segment and is also perpendicular to the segment. So that's line L here. Any point I put on line L, doesn't matter where I put it. Let's say I put it right here. I'm going to call this point X. Is the distance from X to A going to be the same as the distance from X to B? Yes, absolutely. And by the way, we can prove that it is. So if I joined these and I joined these, this is going to be a right angle also. By the reflexive property, that side's congruent to itself. Those two triangles are congruent triangles by side angle side. So that means that AX and BX have got to be equal to each other. This is just an outgrowth of a particular kind of congruent triangles. The interesting thing is we can switch it around. If a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So what that means is something we have already looked at before. If you have an isosceles triangle like this, so J is equidistant from R and from S, then it's going to be on the perpendicular bisector of segment RS. Yes, was that a question? Yeah.
About the first one, so I understand like how it's side equal side, but how is it also not side side side?
We're proving that AX and BX are the same length.
Oh,
And then you can't prove it then.
I got his question.
You got it?
Yeah.
Okay. All right, so that allows us to do some problems like these. And I think you're going to find that at least today's problems are mostly like, really? That's all there is to it? They're really pretty straightforward, pretty easy. This is not a hard unit, although you'll find that there's a lot of vocabulary, more vocabulary than we usually have. Okay? All right. So here, if we're trying to find the length of MN, well, this segment that goes through N that's perpendicular to MP is a perpendicular bisector. So N is equidistant from M and P. So that's 3.5 centimeters. This one is the converse. Here we have a point A that is equidistant from K and R. Since it's equidistant from K and R, it must be on the perpendicular bisector of segment KR. And if that's the perpendicular bisector of KR, if that's 18 inches, so is this. And then the last one is just an algebra example, very much like the first one. We've got a perpendicular bisector of segment JD. Therefore, TJ and TD have got to be equal to each other. So 3x plus 9 is equal to 7x minus 17. That'd be 4x is 26. So x is 6.5. So then JT, which is what they asked me for, will be 3 times 6.5 plus 9. So that's 18 plus 1.5 is 19.5 plus 9 is 28.5. So if we have a perpendicular bisector, any point on it is equidistant from the endpoints of the segment, or vice versa. If we have a point that is equidistant from the endpoints of a segment, it's on the perpendicular bisector. The other one we have is going to be about angles, but first we're going to do this. Write an equation in point-slope form of the perpendicular bisector of the segment with endpoints 6, -5, and 10, 1. All right, so first of all, do you guys remember point-slope form?
Yes.
No, never mind.
Kinda.
MX.
No.
No.
So
The over and the
Y equals mx plus b.
that's slope-intercept form.
Oh,
Oh, is it? Wait.
that's
what I
what
was.
Yeah, y equals mx plus b is slope-intercept form. That's the one that Algebra 1 textbooks spend a lot of time on.
That's like the most basic one.
Yeah, I'm sorry?
No, I know he's right. No, is it?
So point-slope form, there's a couple of different ways that you can write it. This is the way I like to write it.
Oh, it's this one.
Yeah,
See, that did not happen in my brain when you wrote that down. I'm just gonna be perfectly honest.
that's
Yeah,
fine.
So we did m times or in
Oh, I know how
parentheses
to read
x
that.
minus x1 and then plus y1. So we just had the y1 in there.
Oh, okay.
So that was our difference.
The reason that there's two reasons why I prefer this. One of them is a calculus reason, and I won't even try to explain that. But the other reason I like this one is because what it tells me is start at this height, and this is how much I'm going to move up or down the M as I move left or right of point x1. So it's a starting point and how much you're growing, okay, to me, that makes more sense. And again, there's a really good calculus reason for doing it in this order. If you put the y1 at the end, that's fine. Doesn't matter. Right? It's equivalent. Some people write it y minus y1 is equal to m times x minus x1. That's another one that you'll see. That's also point slope.
Oh, that's really weird.
The nice thing about this is that it makes it easier if you're going from the equation to the points to just look at it and go, oh, I know what those are. Here you have to think a little bit more. Okay, so in order to write the equation for any line, we need two things, always, and we always need the same two things. Students think that it's one thing or another. No, it is always two things. What do you think those two things are that we need? What's one of them?
Intercept.
No,
The slope.
we do not need the intercept. That's what students think. They always think, you got to have the intercept. No, we don't. What do we need?
The slope.
We got to have the slope, and we need a point. It can be the intercept, but it doesn't have to be the intercept.
Oh, that's what I meant. Intercepts are like on the line, right? I just meant
On the axis.
Yeah, I just meant like a dot on the graph.
Yeah, we need a point, we need a slope, which is why I prefer point slope. And when you get further into math, the further you get, the more you use point slope and the less you use slope intercept. All right, so we need a point and we need a slope. Okay, so first, it tells me we're going to do the perpendicular bisector of the segment. Okay, so I need the midpoint. We did this a long time ago. This is part of why I like to end the semester with this unit. Do you remember how to find the coordinates of the midpoint for this?
Subtract. Add
Add what?
y1 and
Nope,
yeah, technically
nope.
no.
Okay, so
X.
it's y1 or y2 minus or
Nope.
oh, it is plus, and then it's divided by. I don't know what. Oh, I think I was thinking of the other.
You're thinking of the slope equation.
Yeah.
We're so smart, guys.
I still don't get it.
We're taking the two x coordinates and averaging them.
Uh-huh.
That's how you find midpoint, is you average the coordinates.
Oh. I get it now, guys.
Yes?
Really bad question for the unit that we're in.
It's
because
okay.
It's not about it.
It's okay.
Couldn't you just do that and then put both of them over, like the whole thing over two, instead of like each individually? No.
But we want the coordinates, plural. We want two different numbers. So that 16 over 2 is 8. And negative 4 over 2 is negative 2. So that's the midpoint. We want to go through the midpoint, so that's our point. Then, let's find the slope of the line.
Let's.
And I guess they called it a segment, so I'll call it the same thing. Some of you were trying to do this earlier. How do you find the slope of the segment?
Subtract.
Subtract what?
Y.
All right, so negative 5 minus 1 over 6 minus 10. So it's negative 6 over negative 4 is positive 3/2. Now, we don't want to be parallel to this. We want to be perpendicular. So the slope perpendicular to the segment is going to be what?
Flip it to negative.
Yeah, negative 2/3. Take the reciprocal,
Reciprocal.
is the word for flipping the fraction, and you take the opposite sign. So now all that's left for me to do is substitute into the equation and simplify anything that I can. So that'll be y equals negative 2 plus, well, I'm going to rewrite that as minus, because I don't want to write plus negative 2/3 and have to take an extra step. Minus 2/3 times x minus 8. So that's a good review for you of the slope formula, the midpoint formula, how to find perpendiculars. All right, before we go on to the next part, let me ask you a quick question. Does that blue ray bisect the angle?
No.
You can never assume.
Does it appear to?
No.
Why not?
It's not in the middle. They're not equal. The angles are not congruent.
Okay, the angles aren't congruent, but what else were you saying? It's not in the middle. It's closer to one side than the other side, right? If it's going to be an angle bisector, it needs to be the same distance from the two sides, right? That's what this theorem says. If a point lies on the bisector of an angle, then the point is equidistant from the sides of the angle. And the converse is also true. So if these two angles are congruent, then those two segments will be congruent. That's the distance from the point to the side of the angle. Right, when we're measuring the distance from a point to some line, you always have to be perpendicular to the line. That's why these have to be at right angles. If I'm measuring the distance from N to KR, I'm not going to go over here someplace, am I? I want to go the shortest distance, which is along a perpendicular. And conversely, if these two are the same length, then this must have been an angle bisector. So here, AC bisects angle BA, whatever that is, looks like a P. Therefore, any point on that, like C, is going to be equidistant from the two sides. So CD, oh, I guess that's a D, has got to be 3.8 feet also. This one turns that around. Point T is equidistant from RQ and RS. Therefore, this must be an angle bisector. So x squared plus 2 must be equal to 2x plus 26. You can let her in. She just made it here early. So to solve that, what we'll do is subtract 2x and subtract 26 from both sides.
Can I start my test?
Now, give me a minute to finish this up. I thought you were going to take it after school today.
I have to do English too.
You have to do,
I have an English.
okay, gotcha. All right, so this is going to be x squared minus 2x minus 26 is equal to 0.
Wait, when did we minus 20?
Oh, minus 24, thank you. Who remembers how you solve problems like that?
The X thing.
The x thing.
Yeah.
We're going to have to factor this. What is this going to factor to? Yeah, so this will be x minus 6 and x plus 4. So then either x minus 6 is 0 or x plus 4 is 0, which means that either x is 6 or x is negative 4. Which means that we're going to get two different answers for the angle. When x is 6, we're going to have 6 squared plus 2 is 38 degrees. Or, when x is negative 4, we'll have negative 4 squared plus 2, which is 16 plus 2 is 18 degrees. Okay, unlike our previous unit, the one have been working on now on right triangles, this unit, everything's a book assignment.
No. Why?
Happy birthday.
So tonight's assignment is out of the book.